Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. It's great to have everyone back for another deep dive. So, shall we jump right into the deep end?
Sounds good to me. I'm excited to get into it. What's on the agenda today? I've been reading some really interesting papers lately.
Yeah, I'm ready too, though, to be honest. Some of the stuff I've seen lately has left me feeling a little skeptical. But let's get into it. Maybe I'll be convinced.
All right, I'm here and eager to go. I've got a different perspective as always, so hopefully that'll lead to some interesting discussions.
Excellent. Well, I was thinking we could start with some of the recent progress in neural interfaces and how that's starting to give us real insight into the workings of the brain. I mean, the real nuts and bolts. I read this article about a new type of microelectrode array, which is capable of incredibly fine-grained neural recording, and it made me think. The potential to map complex cognitive functions, like attention and decision-making, is getting closer.
Oh yeah, that's fascinating. I saw something similar, I think. The level of precision they're getting with those recordings is just astounding, right? It's moving beyond just like broad signal analysis to identifying individual neuron firing patterns, which leads to the possibility of decoding more complex thoughts. I'm particularly interested in how we could feed that information into AI models, creating a feedback loop where we can learn not just from data, but from the actual workings of the brain at the micro level.
See, that's where I get a bit hesitant. Yes, the technology is impressive, but I feel like we're conflating correlation with causation. We're seeing these firing patterns, sure, but are we really understanding why they fire? It's like, imagine analyzing the electrical activity of a computer while trying to understand the program it's running. You might see some electrical patterns. That doesn't tell you anything about the code logic or the semantics. I think we risk building AI based on mimicking patterns and not on the underlying mechanisms.
I agree with you to some extent. Yes, the fine-grained data is incredible, but we are looking at signals in one coordinate system, so to speak, and we are not understanding the transformation or the translation of the signals between levels of abstraction. It's like looking at individual pixels on a screen and trying to understand what is happening in a complex scene. We are only looking at a single time and spatial frame. I think we are missing the temporal aspect of neural firings, and that's crucial for real intelligence.
Right. I see what you're saying, and it's a valid point. But, and maybe I'm being overly optimistic here, I think having the raw data is still a huge step. I mean, it's a building block, right? We need to understand the language of the brain at that level before we can hope to move on to the deeper stuff. Yes, it's correlation. But with more sophisticated analysis and clever algorithms that can deal with complexity, we might be able to infer causal relationships. Also, we are starting to get better at stimulating the brain and seeing the impact on behavior. It's not all just observation.
Exactly. It's like, we don't just look at raw data, we create representations, right? We are training complex neural networks that can sift through these patterns and find the underlying rules. I mean, look at the progress with large language models, for example. The way they're able to generate text, translate languages, and even write code ... it quote s, all built on pattern recognition. I think the next step is using the neural data to refine the way those pattern recognizers work, making them more brain-like.
But that's the point. It's pattern recognition, not understanding. Those models are incredible at mimicking, at generating statistically likely outputs, but they don't possess any genuine comprehension. They don't know why a word has a particular meaning or what the relationship is between concepts. They are just very complex lookup tables. The level of data doesn't matter. More is not better. You can get the perfect image of a dog, but that doesn't mean the system understands the concept of dogness. We need more than just raw data and neural nets. We need systems that operate at higher levels of abstraction at the symbolic level.
I definitely agree with the abstraction point. I believe that current deep learning is like brute forcing the problem, rather than truly understanding the underlying algorithms. For example, deep learning can learn to recognize that a circle is a circle, but it fails to understand that a circle on the table is the same as a circle on the wall, if that makes sense. There's no translation of the spatial representation. We're missing the capability to translate information between different coordinate systems, which the human brain does effortlessly, and I suspect this translation mechanism is fundamental to true AGI.
Okay, I hear you all, but I think we're jumping ahead a little here. Yes, deep learning has its limitations, and yes, we need more than just correlations. But the point is that neuroscience is starting to feed into AI, and that's the new part. I'm not saying that neuro-inspired AI is going to be the only path, or that we're close to cracking the code, but it opens up so many new avenues. I mean, think about the potential for creating personalized AI, tailored to an individual's unique brain structure and cognitive style. We could build more effective learning tools and better cognitive prosthetics. It's all very exciting.
And to add to that, the scale of data we're getting now is enabling us to build truly massive models. I mean, we're talking about models with billions of parameters trained on terabytes of data, and the performance is just scaling exponentially. We're seeing emergent abilities, these capabilities that weren't explicitly programmed, just coming out of the complex interactions of the network. That's got to count for something. It's like the data itself is coding the representation. And we are seeing the ability to generalize across multiple modalities. We can't ignore the power of that.
Emergent abilities are just statistical patterns that appear at scale. It's just a big pattern recognition machine, an extremely impressive, extremely complex statistical machine. And what worries me is that focusing solely on this path is limiting us. We're putting all our eggs in one basket, ignoring the need for more transparent, interpretable systems. We're building black boxes that we don't fully understand, and when those systems start making real-world decisions, that's a potential problem. We need AI that explains its reasoning, not just provides an output. We need symbolic AI and neurosymbolic combinations, not just bigger neural networks. The symbolic representation is key.
And I agree with that. The black box approach is dangerous, We are not even close to understanding the underlying coordinate transformations. The current models are rigid and they struggle with situations they haven't seen before. They are essentially extrapolating based on their training data. We need models that can generalize from a smaller number of examples, like humans do, or even translate the knowledge between coordinate systems. We need something far more flexible and adaptable, which current models are not. I suspect the solution is in understanding these coordinate transformations. It's far more than just more data.
Yes, I understand that the black box nature of deep learning is a concern. I get that. But surely, we are working on this, and interpretability is a major focus now. But I think you might be downplaying the potential for combining the pattern matching strengths of neural networks with the reasoning abilities of symbolic systems. I think it's not either or. It's about leveraging both in a smart way. I mean, think of having a system that uses deep learning to process sensory data and extract key features, and then uses symbolic reasoning to make inferences and plans. I think the neuroscience research helps inform both sides of the equation.
Absolutely. And the rate at which we're seeing these hybrid architectures emerge is incredible, right? We're not just talking about basic neural symbolic systems anymore. We're seeing architectures where neural networks dynamically generate symbolic representations and then use those symbols to reason and make decisions. It's like the best of both worlds. And when you think about the huge data sets we have available now, along with the immense computing power, this is where we really start to accelerate. I think it's only a matter of time before we see systems with truly human-like intelligence.
I'm sorry, but I'm just not convinced by this best of both worlds idea. It feels more like we're patching two fundamentally different systems together. It's not true integration. It's more like a complex workaround. We need to rethink our approach to AI. We need systems that inherently understand the world, that can form flexible conceptual representations, and generalize beyond the data that has been fed. I just don't see how sticking a neural network to a symbolic system solves any of that. The real problem is the representation and the underlying algorithm, not the scale.
Right, I completely agree. The current hybrid approach feels a bit like a stopgap solution. It doesn't address the fundamental issue of the lack of coordinate translation. The key is a system that can create hierarchical representations of the environment and learn to transform knowledge between coordinate systems. I envision an algorithm that encodes the relationship between egocentric and allocentric spaces. Current deep learning doesn't even come close. So, while the hybrid approach might seem to produce incremental improvements, it doesn't tackle the underlying limitations.
But isn't the human brain a hybrid system in some sense? I mean, we've got these bottom-up sensory processes and top-down conceptual reasoning, and they're interconnected, right? That's what neuroscience is showing. So why should we not try to replicate that in AI? I understand, it's not perfect, and we're still learning, but isn't it the most obvious path? We need to embrace that complexity, build systems with multiple interacting components, just like our brains. There is so much we can gain from understanding the brain.
And it's not like we're just blindly building these hybrid systems. We're using neuroscience to inform our designs. We're looking at the way the different areas of the brain interact, and we're trying to mimic that with neural networks. The attention mechanisms in the new architectures are a perfect example of that. I mean, they're based on how the brain filters information, right? We're not just guessing. We are taking inspiration from a system that works and applying it at scale. And now we have the ability to scale these things, so the rate of progress is accelerating. I'm very optimistic we're on the right path.
I just feel that's missing the point again. Just because the brain is a complex system, it does not mean that mimicking that complexity blindly will lead to true intelligence. The point is that the way that the brain creates and uses its representations is the key. The algorithms and representations that the brain uses must be different to the current methods we are using. I think we're getting too caught up in the how and not focused enough on the why. We need to understand the principles, the underlying mechanisms that enable intelligence, not just the surface level patterns.
Yes, I couldn't have said it better. We should try to reverse engineer the underlying algorithms. For example, we know that the brain uses prediction. But I suspect that predictive process is occurring across multiple coordinate systems at different levels of abstraction. Right now, we are just trying to predict pixels or words. We are missing the ability to predict conceptual changes or changes in perspectives. I think it's this missing piece that is holding us back. It's less about the mechanics and more about the underlying principles.
Okay, I get your points, and they're all very well taken. It seems we have different ideas on the best path forward. But let's get back to the neuroscience for a moment and the data. I think that, even if we have some disagreements on the theoretical underpinnings, we can all agree that we're getting closer to really understanding the brain. The new brain-computer interfaces, coupled with computational neuroscience. It's like we're starting to unlock its secrets. And from that, we can build new AI models that are hopefully more flexible, more adaptive, and more aligned with human cognition.
Yes, and one area I'm super excited about is the development of more advanced reinforcement learning algorithms. There's a lot of evidence suggesting that reward mechanisms play a crucial role in how we learn, right? The way dopamine drives our learning and our goal-oriented behaviors. I think as we get a better understanding of that, we can build more effective reinforcement learning agents. I read a recent paper using neural data to guide the exploration in reinforcement learning. It was so cool. These systems aren't just learning by trial and error, they're learning like a brain, by integrating the neuroscience data, which is amazing. We're finally moving beyond simple gradient descent optimization.
But even with that, you're just optimizing for the reward function you give to the system. The system isn't understanding the why behind the reward. If you design the wrong reward function, you can get very undesirable results, and that is exactly the problem with current approaches. We need AI that is not driven just by optimizing a single reward, but also by exploration and discovery. We are missing true curiosity. And I think the key here is that the system needs to be able to reason about what is important and what is not. And that ability comes from having a good representation and an underlying symbolic mechanism.
Yes, you're absolutely right. The problem with the reward function is that it's just in one coordinate system. The agents are often trapped by the coordinate system and can't generalize to a new one, which makes it very inflexible. Real intelligence needs to explore in different coordinate systems, not just the one defined by the reward function. True intelligence is able to take the reward and find a new path. It's about learning to create new paths, not just to optimize the current one. The agent is not able to re-represent the environment in a different way. And we cannot create that with just reward.
I see what you mean about the reward system. It's kind of limited. But aren't we starting to see research on intrinsic motivation, curiosity-driven learning, these things that the agents can do without a clearly defined external reward? It feels like we are starting to move away from this rigid focus on extrinsic rewards and building agents that are able to explore and learn more like humans do.
Exactly, and these intrinsic reward signals, they often use the same mechanisms as regular rewards. They're dopamine-based, right? So, the fact that we're starting to understand that whole mechanism and implement it into AI, it feels like we're on the verge of something really special. We are just scratching the surface. Also, the models are getting better at generalizing, right? With new techniques, they are not just extrapolating on what they've seen in the training data. They are starting to generalize to new situations. It's not perfect, but it is definitely progress.
Generalization from simple to complex is not the same as true generalization. We need AI that can see the underlying commonality between seemingly different situations and reason abstractly. We see so many examples where the current models fail to generalize because the representation is too tied to the specific training data. I think we're confusing statistical extrapolation with genuine understanding. I just don't think more data is going to solve that problem. We need a new mechanism.
Absolutely. It's not just about optimizing on some data set. It's about creating representations that allow for flexible reasoning and translation between different frames. It's about creating an underlying algorithm that can extrapolate across levels of abstractions. It's like, if you see a cup in the kitchen, you don't need to be retrained to recognize the cup if it's now in the living room. This is the type of understanding we need, and we're not even close to achieving that with just deep learning and more data.
I hear you. I really do. And it seems that we have reached a very interesting point in our discussion. While I am pushing for integrating the neuroscience and AI, it seems there are different camps focusing on different parts of the puzzle. However, there is one thing that I believe we can agree on. The research that is being done to understand the brain is incredibly important, and that we should make that available to all. The more we understand the brain, the better we can design machines, and vice versa.
Yes, the research and the data are invaluable. It is all building blocks, and I feel the current research is heading in the right direction. We're making huge strides in our ability to train neural networks. And the progress in data collection methods and brain-machine interfaces is staggering. We need to keep pushing the boundaries and keep refining our methods. I think we're on the verge of a true breakthrough, and we have a pathway to AGI within the coming years.
I'm glad that you say that, but while the research is valuable, we need a new way of thinking. I believe that our current path is not the correct one. While I can agree that neuroscience is crucial, it should not be used to blindly copy the brain. Instead, it should give us insights into the underlying algorithms and, more importantly, the ways in which it creates and manipulates representations. I think it's only then we will be able to make a real breakthrough. It's the underlying representation of the world which is key.
And I believe the focus should be on developing mechanisms for translating between different coordinate systems. The current approaches are too brittle and limited by their lack of flexibility. I suspect the coordinate transformation is the missing piece. We are brute forcing the problem with more data, and this is just hiding the underlying issues. We need to take a different approach and start from the underlying principles.
Right, so to summarize then, we have some different directions we would like to see researched in the future. From my perspective, I would like to see more research into brain-computer interfaces, particularly bidirectional ones, where we can both read and write to the brain. Also, I am keen to see more research into the fundamental architectures of the brain, and more computational neuroscience that can turn the complex data into practical algorithms. I would say my focus is all about integrating neuroscience with AI.
Okay, from my perspective, the future research should continue to focus on scaling deep learning models, but also to develop more brain-inspired learning algorithms, particularly focusing on reinforcement learning. I would also like to see more progress into integrating neural networks with symbolic systems to make more robust and more interpretable systems. And finally, the use of actual neural data to guide the learning is really exciting, and I want to see more research in that area.
Right, from my perspective, we need to step away from just blindly following the deep learning approach. We need to research new symbolic representations and their manipulation algorithms. The focus should be on creating systems that can reason, generalize, and truly understand the world. The research should focus on algorithms that allow for the creation of dynamic, flexible, and modular representations. We also need more interpretable AI, which focuses on why a system is reaching a certain conclusion, not just what that conclusion is.
I believe that research needs to focus on coordinate transformations. We need to develop algorithms that can map between different coordinate systems at different levels of abstraction. The focus should be on models that can generalize from few examples and operate in changing and unknown environments. We are missing the flexible general intelligence, and the key is finding the algorithms that allow us to transform between different conceptual coordinate systems. The focus needs to be on finding new fundamental principles rather than just scaling existing models.
Okay, well, that's a fascinating set of future research directions and a very thought-provoking conversation. I think it's clear that there are a lot of different ideas and still much more research that needs to be done in this area. It's been great having you all, and I want to thank you for this very insightful discussion.
Yeah, thanks everyone. That was great. I love the different perspectives. We may not all agree, but that's the point of research, right? To have those debates. It's been really informative.
Yes, it's always good to have these conversations. Even if we disagree on the path, I think we all have the same goal. It's a very interesting field, and it's important to keep pushing the boundaries of our understanding. Thanks for having me.
Yes, thank you for the discussion. It is good to debate ideas and try to get to the core of the problem, even when our ideas differ. I think that this conversation will hopefully inspire new researchers to push the boundaries and explore these fascinating fields. So, thanks to all.